The tire of a car has a radius of 9 inches, and the person rolls the tire forward at a constant rate on level ground as shown in the figure. Point W on the edge of the tire touches the ground at t equals 1/2 seconds, and the tire completes a full rotation. The next time the tire touches the ground is at t equals 5 seconds. The maximum height above ground is 18 inches. As the tire rolls, the height of W above the ground periodically increases from increasing to decreasing. Okay, so let's get started with what we know. Let's first start this. We can see that one complete revolution will be from 5/2 minus 1/2. Now, I personally like working with decimals better. I know 1/2 of 5 is 2.5 minus 0.5. That means one full rotation will take 2 seconds. Also, remember we're working with the sinusoidal curve here, and it's broken into 4 steps. Step 1, 2, 3, and 4. So when I divide this by 4, I end up with 2 over 4, which is 1/2. So each one of these steps takes 0.5. Remember, it touches the ground at 1/2, and it touches the ground at 5/2. So if I come down below, and I'm going to have to come back and change this, and I'm going to tell you why in a second, but I know it touches the ground here at 1/2, so t is 1/2, and it's 0 inches above the ground. Over here, it touches again at 5 steps and 0 inches above the ground. Okay, and by the way, I like working with decimals, so 0.50, and this would be 2.50. But that would create, if I'm going to go, each one of these segments is 0.5, right? So 0.5 and 0.5 is 1, 0.5 and 0.5 is another one, for a total of 2 seconds, this horizontal distance. So if I'm at 0.5 and I add another 0.5, I'm at 1.0. And remember, it is a total height above ground of 18, and the center of the radius is 9. So 9 up, another 9 for a total of 18 inches above. So the height here is 18, and the height here is 18. The height here is 9. It's midway up. The height here is 9. So we're going to keep adding segments of 0.5. So plus 0.5, plus 0.5, right? Here would be plus 0.5, 2.09, 2.0. Here's 2.5 and 0. Let's go the opposite way. Let's subtract 0.5 to get 0. And let's subtract over here. Let's subtract 0.5 to get a negative 0.5. All right, so this is what we're looking at right now. But here's the problem with that. We are supposed to label F, G, J, K, and P, and I'm not sure that AP scores want us to have a time in terms of a negative amount. And for that reason, I'm going to adjust this. So I'm going to make this the 1.5 because we know that's a positive t value. So let's just change this. I'm going to change this to make this 1.5. As a reminder, as we move to the right, we're simply going to be changing here. So by 0.5. So 1.5 plus 0.5 is going to be 2.0. And then this would be 2.5 and 0. And this would be 3.0 and 9. And this would be all the way up to 3.5 and 18. And down to, this isn't a point we have to graph, but we can see that, right? So I like these points right now. And the reason is that I'm not sure if the scorer wants us to have a negative time value. So I know that 1.5 represents one of the highest points, and 1.5 to 3.0, that's a distance of 2. That's exactly what we want. Okay, so I feel comfortable with 1.5, 18, 2.9, 2.09, 2.50, 3.09, 3.5, 18. Feel comfortable with that. Definitely why we want to use a pencil. I don't want there to be any confusion here if I had an AP score reading this. Now I'd do this one. Okay, all of that looks good. Okay, now let's go down below, and maybe it would have been even helpful to draw this table. Remember, we don't want them to question. If you happen to have messy handwriting like I do, then it may be valuable for you even just to make a table off to the side, as I've done with other practice FRQs. And we're going to make this a 1.5. This is my time. This is going to be my h of t, and this is going to be my points. So 1.5, 2.0, 2.5, 3.0, and 3.5. This is height 18, 9, 0, 9, 18. That may be invaluable to do along with this to make sure that they can read. Let's go down below and let's now identify A, B, C, and okay. So our A is going to be our amplitude. We can already see our amplitude is going to be 9. So from this midline, we go up 9 or down 9 to read the maximum or the minimum. We can see our midline is going to be at 9. Let's figure out our B value. So our B value is going to be 2 pi divided by B, and I'm going to set it equal to whatever our period length is. So our period length from 1.5 to 3.5, as I've already shown up above, is going to be 2.0. Or 2. Okay, let's cross multiply. I have 2 pi equals 2b. I divide by 2, and I end up with b equals pi. There's a couple different ways that we can translate this. A couple different ways we can translate this for C. I'm going to count backwards right now. I know this is a 1.5. That would make this 1.09. Okay, it's going to be right about here. That's going to be 0.5 and 0, and back up here at 0 would be 0 and 9. And so how can I translate this? I want it to look like this. I want it to look like a sign that has this hump, and then down below we have this valley, right? So it looks like a rainbow, and then we have this valley. So what can I do? Well, I'm looking right here at where x or t equals 0, and I recognize one way, and there's multiple ways you can do this, is if we reflected this over, the midline, notice that's exactly what I want. Well, how do I show that? To reflect over the midline, this value, A value, actually turns into negative. So A equals negative 9, B equals pi. I don't have to do any shifts then, so E equals 0, and D equals 9. So this would be my final answer. Let's look at C and D, and we're going to refer to this graph. So it says that we want to declare K to be T sub 1, and we want to declare P to be T sub 2. All right, well, we know that the Y values or output values are positive, so that means I can eliminate C and D. We also can see that it is increasing at this point. Let's go down to our second option. How is the rate of change on this function H from T1 to T2? Okay, so I can see that H is positive and increasing on the interval T1 to T2, and it has a decreasing, can't see anything, sorry, has a decreasing rate of change, making it concave down. I'm sorry, my handwriting is so sloppy. H is positive and increasing on the interval T1 to T2, and has a decreasing rate of change, making it concave down.